Good morning, Amy. How are you doing?
Good morning, sir. Yeah, I'm doing well. How are you?
Very good, very good. So last time we talked about circles and things like that. Did you understand that lesson?
Yes, it was very clear. We first kind of touched upon the last lesson before that, which was unit conversions and things like that. We saw it in more of a real life applications in word problems. So that was really nice to see multiple conversions in one place. Then we touched upon the three equations. So the first one was of arc length, which is radius times theta. All of these should be in radians as the default. Units for angles. And then we learned about, just a quick refreshment back to the basic trig that we learned with SOHCAHTOA, sine law, cosine law. And then we touched upon the chord length, which is one that I did not know of. So that's when we found that we know that the diameter times sine A, where A is the angle, well, you could say at the circumference, but then you need to know that it's half of, because according to the circle theorem, you can also have theta over 2. So both work in terms of, you should know which angle you're dealing with, basically. Perfect. And then the last thing we touched upon was the area of the sector, which was the half r squared theta. So yeah, I kind of got the concepts around that. And then what was the main part you were talking about, with the sine law being A over sine A equals B over sine B, and then that constant K is that diameter of the circumcircle inside. So I didn't know that either. So yeah.
Correct. So you have beautifully summarized our last lesson, and that gives you a set of formula to begin with and where we left. So we'll actually begin from here and continue towards area of sector. As you said, we touched upon that, and now today we'll get into details about it, and we'll see many Cambridge University examination style questions, which are based on this particular topic. Okay.
Perfect.
So let me share with you our lesson. Perfect. So can you see my screen here?
Yes, I can.
Okay. So, right. So this is area of the sector. A part of the figure is actually hidden under our picture. That's a problem. Anyway, let me just type it out. So I can highlight here. Fine. So we'll talk about area of a sector. Area of a sector really means that in a circle, when you have an arc which is enclosed by the radius as shown here, then this shaded portion is the sector, right?
Yeah.
Like a pastry, like, or you can say is a slice of a pizza.
Yes. Yeah.
It's kind of like that. That's the sector which we are talking about. Now, clearly seeing, because of the infinite symmetry of the circle, the area of the circle and area of sector are related, right?
Mm-hmm.
Area of sector is part of that particular circle. And therefore, I can say that area of sector divided by area of circle should be equal to the angle in the sector over angle of one complete revolution. Perfect? Mm-hmm. So that means area of the sector which we need to find, what should it be? We are going to derive the formula today. Divided by pi r square, we know that is the area of circle. Mm-hmm. Angle theta subtended by the arc, as shown in red here, divided by 2 pi, the full circle in radians. Perfect? Yeah. So that becomes the proportional statement, correct? Cross multiply, you get area of the sector as theta over 2 pi multiplied by pi r square. And now you can simplify this by canceling pi. You get half r squared theta. So that becomes area of the sector. Please make a note of this particular formula, right? So area of the sector here, you cannot see the formula there, and therefore I'm writing it half r squared. So that is the area of the sector. So now we know what area of sector is. And before that, we learned few formulae. Let me list them out. We learned a formula which is giving you the length of the arc, which is A, which is equals to r theta, correct?
Yeah.
Right. So what was the, what are the other formulas? Can you tell me?
The chord length one. Which
chord
was the diameter times sine A, where angle A is the angle at the circumference.
diameter
or sine
times
theta.
this, we'll talk about the central angle, right? So it is sine of
sine theta over
by
2.
2. Is that clear to you?
Yeah.
So that becomes the chord length, correct?
Yeah.
Arc length is r theta, the chord length. If we connect the point A and B, we get a chord, right?
Yeah.
So right? Then we get this chord A and B, and that length is d times sine theta by 2. So as you can see very clearly, to find the arc length, to find the chord length, or to find the sector area, we need theta, the central angle.
Right.
It should be in radian. If it is given in degrees, you should convert it to radians, right? And that brings us to the other set of formula, which is, we know pi radians. Radian is a ratio. So normally we don't write any unit for it, is equal to 180 degrees. And that will help you to convert from degrees to radians. Is that clear?
Yes, yeah.
Now, to help us get this chord length formula, what did we use? We used the sine law, correct?
Law.
So we learned that sine, I should write A over sine.
Yeah.
A over sine A is basically, let me write this as capital A, the angle, correct?
Yeah.
It's basically equals to B over sine B equals to C over sine C. That is the sine law. And all this is equal to the diameter. So we had inscribed a triangle within a circle last time and showed and proved it rather, right? So that's constant is the diameter. And clearly from here, we get a formula that A is related with diameter times sine of angle A. This angle will be at the circumference as shown here, the angle A in the diagram. Is that clear? Perfect.
So, but when we do it with these angles and things, we don't need to convert anything to radians or anything. It's just the simple sine law.
You're right.
Oh, okay.
That's the beauty. So because as you can see, we're talking about this angle and this. No. Here also, you have to convert these angles to radians, right? Convert.
Oh, you do? Oh,
yes.
okay.
So angles in radians. So always radians will be the angle, correct?
So let's say we had an angle of 20, you'd convert that to radians and then sine of that value.
Correct.
Oh, okay.
Correct. Now, because this will be a constant diameter. You are right, I mean, in this particular case, in this formula, sine law you mean, right?
Yeah.
No, it could be in degrees also.
Oh, is it just because it's a ratio?
It's a ratio.
Oh, okay.
So that could be in degrees, but all other angles, once you start using here, because diameter is like centimeter, right? It does not have radian or degree in it. Once you see the diameter, it is length unit, correct?
Yeah.
So, but when you have to use your formulae, otherwise you have to use in radians. Perfect?
Okay, yeah.
Right. So A over sine A, you can find the ratio using anything. Because if you use, let us say sine 60 degrees, right? So if you use your calculator, you write pi by 3 for that. Correct?
Yeah.
So you get the same result. You understand?
Oh, I see. Yeah.
You mean, let me just draw this triangle.
Because pi by 3 is 60 degrees, but that pi by 3 is in radians.
Yeah. For the calculator, I mean, let's say this is 60 degrees, right? So we know that the sides of this particular triangle will be 1, 2, and square root of 3, right?
Yeah.
So if your angle is 60 degrees, then you will say your sine theta is what? Your sine theta is equal to square root 3 over 2, correct?
Yeah.
But if you have here, instead of 60, if you have pi by 3, so your sine pi by 3, that will also give you square root 3 over 2. Do you get the idea?
Right. Yeah.
So it doesn't matter. Of course, you have to use your calculator in correct mode, right? You cannot use your calculator in radian mode and put in degrees in there. Perfect. So,
but it doesn't matter if I use degree or radian.
Yeah, it doesn't matter, right? So because you get the same result, we are interested in the result, which will be a number, correct?
Okay, yeah.
Perfect. So you have understood the sector formula very clearly, simple as that, correct? So it is again similar to arc length, because arc length was also a ratio of circumference, right?
Yeah.
So we got that formula from there. Now, based on this, we could have very complicated questions. So we'll begin with simple ones. Can you please read example number 17?
Yes. So area of a sector. So find the area of the sector of a circle with the radius of 4 centimeters and angle 3/4 pi.
Correct. So you know the formula, which is half r squared theta, right? As simply all the values are given to you, substitute the values and get your answer. Is that clear to you? Perfect.
Yeah.
Now, the other way is we are given the radius and the angle in degrees this time. So when the angle is given degrees, what will you do? You will convert them to radius. And once you have converted them in radius, then apply the formula, get the result. Simple. Right. So this becomes a very basic question on sectors, correct? Now, let's look into example number 18. Can you please read this question?
Yes. So reverse calculation. So a sector has an area of 21 centimeters squared and an angle of 1.2 radians. Find its area and perimeter.
Perfect. So it's a reverse calculation. This time we have already given you the sector area. So you need to find the relevant parameters, correct? So how will you solve it?
Oh,
begin with the formula, correct?
Yeah. So then make that formula equal to the 21. And then substitute the 1.2.
Yeah.
And then find R.
It has to be positive, right? When you do square root, it could be plus and minus, but always real values, positive length, right? So you get the value of R. Once you get the value of R, you can find the perimeter, correct? Because we know the sector now, perimeter really mean arc length. And AO and OB, you get the
idea. Are the same. Yeah.
So we are not saying arc length alone. We are saying perimeter of the sector.
That could be, because in the Russian exam, you might just accidentally just do AB when you need to also add the radius parts.
Perfect. So twice radius has to be added to the arc length to get the right answer. Apply the formulas which we have already discussed, R theta and 2R, right? So, and you get your result. You get the idea.
Yes. Yes.
Simple as that. So that is how we'll move forward. That gives us the foundation. And now we are back into, good, I have some formula here. Okay, so now we are going to talk about area of segment. Perfect. So we know area of the circle, we know area of the triangle, we know area of the sector, and that clearly brings us that we can actually find the area of this particular segment also. Perfect.
Right, yeah.
So area of the segment will be what? You need to take away the area of triangle from the area of the sector to get the result, correct?
Yeah.
We already know that area of the sector is pi by 2 r square theta. We just derived this formula, right?
Yeah.
Right. The triangle formula, actually I derived earlier, which is pi by 2 r square sine theta, which I have not derived here, but we can just quickly go through this, right? Derivation of area of triangle in this particular situation, not an issue. So we'll just go through it. So let me just make a big triangle here. Can you see my screen?
Yes, I can.
Okay, so I'm trying to make a similar kind of triangle. The only thing is, since we are interested in general formula, we'll take an angle of theta, right? And we'll take this as the radius r. And what we are going to do is drop a perpendicular. Now, since these two sides are same, both are radius r, the angles will be theta by 2. Is that clear to you? Of each triangle. And these are right angle triangles, correct? Where these angles are also equal.
Yeah.
So, now, clear. We know one thing, which is radius. And so we can actually use the angles. Now, in this case, theta by 2 is the angle, correct? When we talk about the area of the triangle, let me say this triangle is ABO.
Okay.
We're looking for area of this triangle as equals to half of AB, which is the base, and let's say this is D, times OD, which is the height. Is that clear to you?
Yeah.
Perfect. So to get OD, we can use theta by 2. So OD we'll use because this is the adjacent side. So we know cos of theta by 2 is basically equal to OD over R, correct? That gives you that OD is equals to R cos theta by 2. Is that clear?
Yeah, cross mark.
Similarly, we can write what AD is. Well, AD will be equals to R sine theta by 2, correct? This is the opposite side, right?
Yeah.
So when I put both the things together, okay, so when I put all these things together, the area of triangle is what? Area of triangle will be half OD is R times cos theta by 2, right? But this is the height, right? And now AD is R times sine theta by 2. We are interested in A to B, right? A to B will be twice, correct? So I'll multiply this by 2 times.
2.
Is that clear? So we have got the formula here. So we could now just cancel one of these 2's. So what do we get? Or just keep it, don't cancel. I'm just telling you why not to cancel. Let me rewrite this. So we have half of, let me write 2 R square sine theta by 2 cos theta by 2, correct? Now, Amy, you've not done compound angle formula so far, but this twice sine theta by 2 cos theta by 2 is sine of 2 theta. Sine twice the angle. So that can be
just like a rule.
Yeah, it's a formula, right?
Okay.
So that becomes half of R square is already there, and that becomes sine theta. Because the formula is that sine 2A is equal to twice sine A cos A. In our case, A is theta by 2. Is that clear to you? So twice sine theta by 2 cos theta by 2 is basically equals to sine 2 times theta by 2, which becomes theta.
Yeah.
You get the idea? So half R square sine theta will be the area of this triangle, and that's the formula which I've written here. Times pi.
Where did the pi come in? Oh.
No, area, pi. Where did the pi go? Half of, where did the pi came from? Wait. So, I think there's a mistake. Half of R square theta by 2, that pi is a typing error. Good. That's a typing error.
Okay.
Yeah, that's this thing. Yes, too small. Okay.
So is sine theta the angle at the center?
Full angle, complete angle. So you see this diagram?
Okay.
Theta was the complete angle, correct? So in our calculations, we didn't find any circumference or area, so the pi cannot come in, right? You understand?
Right, yeah. Okay. But if that triangle was in a circle, would that just be, like, let's say that was the sector, like you did in that diagram there?
Yeah. So we have this triangle here. Now look at this triangle, correct? Triangle OAB, correct?
Yeah.
Okay. We know that the angle O, which I'm saying is theta, is given to us as 1.5 radius.
Yeah.
So that is theta, right? So this is the same triangle. You can say this is the same triangle. The only thing is that the radius is given to us as 6 centimeters. Is that clear to you?
Perfect, yeah.
So now, since we have derived the formula, we don't have to do it again and again. These are the steps involved in deriving this formula. Okay?
Oh.
Well, you could just drop a perpendicular from here, half of the angle, and then find sine theta, cos theta, and multiply and get the result. You could do that. But now every time we should not be doing the same steps over and over. We should derive these standard things and understand how should we use them. Is that clear? So
Can I just ask,
yeah, sure.
Just a random question. Yes. You know, when finding area of a triangle, there's one formula which is half AB sine C. Does that have any relation with that formula or no? Just a random question.
Half AB sine C. Yes. That is also a formula which you can definitely use many times. So area of triangle, there are 3 or 4 formulas we could use depending on the situation, correct? Because if you have a triangle, you could solve the triangle using sine law. You can solve the triangle using cosine law. So based on whether you're given side angle side or what combination side angle, you can use those formulas. And if angle is not given, you use Heron's formula, correct?
Yeah, I remember that.
S minus A times that formula, right? So there are three, for sure, many more formulas which can be used in different situations. Is that clear to you?
Yeah. So if there's ever a situation like this, always use that one.
Perfect. Now, most of the time, when we are talking about circle, theorem, and related questions, which involve sectors and arc lengths, we normally use half r squared sine theta. Normally. Is it clear to you?
Yeah.
As you can see from the diagram, it makes sense, correct?
Yeah, it does.
But of course, feel free to use any formula given what the circumstances are, correct?
Right, yeah.
That's clear. So that's the correction. Half r squared sine theta is the area of the triangle. Perfect. Would be derived, right? Otherwise, we could have got stuck with this formula.
That's true.
Okay, so let's get back to our lesson, which is we wanted to say that the area of a segment is what? Area of the segment should be area of sector, take away the area of the triangle. So from the formula which we just derived, pi r squared theta is the area of the sector, and from there we are going to take away half r squared sine theta, okay? Area of the triangle. Take common factor, what do we get? Half r squared theta minus sine theta, correct? Because half r squared is common in both.
Oh yeah, you just took it out.
So we get theta minus sine theta. So half r squared, and earlier the sector area was theta, right? Now from that theta, we have to take away sine theta to get the area of the segment. You get the idea? Oh. Easy to remember?
Yeah.
So we got our third formula, area of the segment, which is half r squared theta minus sine theta.
Yeah. And it also just clarified that the triangle equation is half r squared sine theta because it's in the...
Yes.
You did it in the question, yeah. Okay.
Correct. All theta is in radians, nothing else. You see, if you put theta and radians, so simple equations to work with. And that's why this is a chord unit. Does it make sense?
Yeah, you would never think, because we're always working with degrees, we're thinking that's easy, but no, it would overcomplicate if you don't have radians. So yeah.
So if I give you theta in degrees, and sometimes to make the things very complicated, what I can do is I can give you this angle. Do you understand? I can give you this angle instead of that angle, the reflex angle. Then you have to take away from the reflex angle, get theta, convert that to radians, and then the answer. You get the idea?
Yeah, instead of giving it to me straight, yeah.
Perfect. I could do that, right? I can say, well, the angle is 240 degrees. For example, I'm just keeping it simple still.
360.
And then you work it out. Is it okay? Now it becomes 120 degree otherwise, kind of. So I'm giving you in degrees, you convert and all that. You know, that could be an examination question for you. Part A, do this. Part B, do that. Part C, do this. And then finally, part D and E, find the chord segment area. Yeah?
Right.
And the perimeter. Perfect. So is this clear to you, how we do?
Yeah, very clear.
Now, can you go through the solution, which we have typed it out here, and the question, please?
So example 19, area of a segment. So find the area of the shaded region to 3 significant figures. Right. So we need to find the area A of the segment. Of the segment. So A equals the area of the sector, which is AOB. And then subtract it from the area of the triangle, which is AOB.
Correct. Same thing, right? So when you talk about this triangle, it is this triangle, correct? So we have to take away this triangle, correct? From the sector. Perfect.
Wait, is AB the
chord?
That chord length? So then how would you say the arc length?
We should have a point here. Let's say we have a point P, APC. APB.
Oh, okay.
Arc length, APB. We have to put a point there.
Yeah. Okay, makes sense. So I guess by using the formula above, you would use the half r squared theta minus sine theta, and the values are given to us, and we have to make sure it's in radians, so we don't need to convert anything. And we're given the angle we need, so we don't need to do any subtractions. So we just sub it in and then use a calculator.
Perfect. So calculator should be in radians to do this calculation.
Yeah. Perfect. Oh, I figured it out how to do with the mode.
Okay.
I realized,
Good. So this is a very basic question on finding the area of the segment, but it gives you the complete concept of how do we do it. And I hope now you have added this formula also into your list, right?
Yes, I have.
And then we can
I've
move
written it all down.
Correct. We'll move forward with some of the
box.
questions. Right. Oh, this question we did last time, right? Can you quickly read through this question, and if there is any other thing we'll talk about?
Yeah. So example 20, area of composite figures. So find the area and perimeter of the shaded region. Given that the circle of the radius is 10 centimeters and the angle AOB is 1.6 radians and the line AB is tangent at E.
Correct. So here we need to find both the things, which is also area and perimeter. So I put area on one side, perimeter on the other side. Now we need to find of the composite figure, which is a big triangle in this particular case, and this, right? So we have to include this arc. Do you understand?
Yes.
We include this arc, this A to C, and that shape. So that is what area we are interested in finding. And now you can use the required formula. We know the angle AOB, that means the complete angle theta is given to us, correct? And the line is tangent, so we know this is at 90 degrees, and now it makes things very simple. So we can first find the area of the right triangle OEA, right? That's simple because we know the height here. The only question now is to find that side AE, right? So how are you going to find side AE? You can use the, because we can use the cos, because we know this half the angle is known to us, which is 0.8. Okay, so 0.8 is known to us, and so we can use this to find this particular thing, correct? So we know, as you can see here, the angle is half of it. We're talking about the triangle AOE. So cos of 0.8 is OE over OA, right? So over O times A. And from here, because we can calculate what OA is, so we find the whole length also. So first we are finding the length, which is 14.35. And now once we have this length, then C to A, which is only this side, could be found. Take away the radius, we got this step, because we need, there is a symmetry, of course, so we can do C to A, which will be same as D to B, because we want to find the derivative, right?
Yeah.
So that C to A is calculated, which is equal to D to A, which we can do that. Now let's get to the R, which is R theta, right? So we know this R. Since the radius 10 is known to us, theta is known to us, so we straight away found this arc length. Now we know this arc length, so the perimeter is twice CA, which is this side and this side. We add perimeter plus the arc length, and therefore, 16 is this side, which we have to still find. So this chord length, how did we find this chord length here? This calculation has not been shown, right? 16? Okay.
Was it just using the formula diameter times?
No. So in this particular case, we have only calculated this. We did not calculate AB, right? So let me just see. No, not that. That's fine. So what you have to do, Emmy, here is that you have to find the length AE and twice that. That part is missing from here because we have to find area and perimeter of the shaded region. Oh, I see. Well, I don't know why this AB was not included. Let us say now if AB is included, let's find AB, right? AB is the opposite side. Let me see. So A to B, I'll write down here, right? A to B is equals to 2 times A to E, right?
Yeah.
Which is 2 times, and A to E being the opposite side for the angle, 0.8, right? So it will be 2 times the length O to A. O to A we found as this, 14.35.
14.3, yeah. Divide.
Times sine of, because this is smaller than the hypotenuse, sine of angle 0.8. Is it okay? So just use calculator. Can you calculate this value?
Yeah.
Different AB.
Wait, it's in radians, right?
Radians, yes, yes.
Oh, okay.
Shift mode and then put this radians on, correct?
Yeah. So 2 sine times 0.8 times 14.35 times 2. 20.6.
Good. I got 20.58, correct.
Yeah,
so,
58.
Right. So we'll add this to this, right? So the perimeter should be, let me write here now. Okay, good. We found all that. So because, I'm just in the process of typing out all these things, there are some errors in typing errors, right? So we can just cover for that. So we have the perimeter now as 59.5 plus 20.56. Is this clear to you?
Yeah, which is 80.1 to 3 SF. Or 80.088.
Yeah, 80.1 to 3 significant figures. Correct. So there you go. And the units are centimeters.
Yeah.
Perfect. So that's good. So Abby, you are actually the one who is going through this book for the very first time with me. And I hope with this, I'll be also making online corrections in my book.
Okay. All right. Yeah.
So
it's good to see that because it makes me understand it more. Because this could be a mistake I would have easily made, in my exam. So I want to see where I would have gone wrong.
So it's a complicated shape which we are talking about. What we are saying is we need to find the perimeter of this shape. Do you see the smiley space here?
Yeah, that. It's a really weird shape.
Like this, right? So we actually find perimeter of the whole shape at the moment, correct? Is that clear to you?
Yeah.
Right. Now let's talk about the sector area, which is actually the shaded region, correct? Inside shaded region. Perfect. So let's find the shaded region. We'll check the correction also. First thing first, which is the area of the triangle. So area of the triangle is half AO square sine theta, right? So that becomes the huge triangle. We just derived this formula.
Yeah.
So it could be used with any triangle, right? Maybe anywhere, right? Once we are given the angle in radians in the center, we can always find. So half of OA, and OA we just calculated 14.35, substituting that value, we get the area of the triangle as so many centimeters square, correct?
Wait, so just a quick thing.
Yes.
I thought the area of the triangle was half r squared. Isn't r the radius? How come OA is the radius?
Okay. So
I might be wrong. I don't know. I'm just asking.
No, you are right, because earlier it was inscribed. So if I have to inscribe this into a circle, then the circle will be kind of like this. You get the idea?
Oh, I see. Yeah. So we just make it a bit bigger. So OA.
Okay. Yeah.
Just checking. Okay.
Yeah, that's a very good question. Now, in GCSE, you will see many questions which will have that circle and this flat portion only. You see that?
Yeah.
Correct. So, yes, it's a very tricky question. So now we have all of a sudden moved from level A to level B, and this involves a lot of other things. So how do you apply the formula? That has to become the radius, because we're talking about that chord length, right? As you remember, let's go back, and then what did we write? We wrote chord length, correct?
The chord length one. Yeah.
Chord length, right? So it has to be a chord length. So to make it a chord length, I'll have to make a bigger
circle. Oh, okay. Got it. Yeah.
So now that becomes my radius. Let me write capital R in this case. Does it make sense to you?
Yes. Yeah.
Very important. So if you do not do that, then you are finding this area.
Yeah. Just the OC part and then that. Yeah.
Which we did in the last example, correct?
Yeah.
So this is kind of an extension to the same thing. I hope you appreciate. So yes. We get this new area, which is the triangle, the big triangle, I should say. Let me just put it here. Yeah, big triangle. And now area of the sector, see, I have extended, right? So the area of the sector is half r squared theta. So now when we are trying to take away this sector, the smaller one, do you see that?
Yeah.
We're trying to take away the smaller one, correct?
Yeah.
That is my smaller sector. So I'm using 10 there.
Oh, yeah. Because OC is 10. Yeah. Got it.
You get the idea? OC is 10.
Yeah. And then OA was the 14.
You have to really see and understand the question. Just don't rush and solve it, right?
Yeah.
And now, once you take away these values, you get your answer. You get the idea?
I see. Yeah.
So that is how a real question will be solved. So we are not directly given all the values, but a very tricky question. I've seen these kind of questions in GCSE earlier also, many times.
Yeah, I think because the main reason is because it's a shading we haven't really seen before. because it's kind of shading it out of it, but then also it can be in when you draw another circle around it.
Yes.
So it's kind of, it's two ways to look at it.
Yeah, so this is the area which we are interested in. Is it correct?
Yeah.
Did you understand this?
Yeah, that was really, it was tricky, but yeah, I clearly understood it.
Correct. Good, good. So we made a correction also. Another very important question from test point of view. So can you please read this question?
Yeah. So example 21, volume of water in a horizontal pipe. So find the volume of water lying in the horizontal pipe of radius 3 meters.
Right. Well, I forgot to write here that the length AB is equal to 5 meters. Right?
Oh,
that is
okay.
also because the water has gone to a level and that maximum width on the top is 5 meters. Right?
Oh,
so
right.
This particular cylinder of water is just standing in this pipe where on the top. So basically, look at it like this, right? So we have something like this, right? And on the top, this length is 5 meters. Is that clear?
Mm-hmm.
This length is 5 meters, correct? Well, in the particular case, the diagram, because I put the center on the top, is a 3D kind of figure. So let me just make a new shape for you.
So is AB the chord?
Is a chord. Yeah, it is. Right. Is that clear to you?
Okay.
So that is how the real situation is. So this is OAB. Is that okay?
Yeah.
So we are saying this is the water. Is that clear?
Oh.
And this length here is 5 meters. And this is 0. This is 3. Okay. 3 meters. That 0, that is for the center O.
If they said a question like that and they didn't put that image like you've done on the side, there's no way I would realize that AB would, like, the water level would come up to AB. That's just hard to see.
Yeah. You're right. Sometimes they don't, but I think most of the time they'll make a figure. They'll make
okay.
Yeah. Otherwise, it becomes a very difficult question.
I was gonna say,
for a student. Yes, very good. So I just hope they include the figure, right?
Yeah. But now I've seen it, I hopefully will have an idea of what could be there because you showed me.
Correct. Since we are talking about the volume, the idea is to get the area of the segment, right? So this is a direct application of area of the segment, multiplying with the length of this pipe, we get the volume. Simple as that, correct?
Right. Yeah.
So you could use the area of the segment formula directly to answer this question. Let me tell you that, right? Because we have this formula which we derived. Is that clear to you?
Yeah.
So I would like you to actually use this formula directly, area of the segment formula, which is half r squared theta minus sine theta. So that gives you the area of this portion. Do you see that?
So I don't need to do any subtracting from anything. Yeah.
And then multiply with this length to get the volume. You are done.
Yeah.
2 minutes.
Oh.
Is that clear?
It's really nice. Yeah.
But individually, how are you going to answer the question? Well, in your case, what will really happen is that they will say part A, find the length of this, find the perimeter, find. So you may have to end up doing
it anyway.
So the formula could be a checkpoint for you. Is that clear?
Yeah, for sure. Yeah.
So in this particular case, as you can see, we are not given the angle. As I said, all the formulas can only be used once you have the angle.
Angle, yeah.
You have to do the reverse calculation to find the angle. So that's the beauty of this example. So we're just talking about 3 examples, but they all have something to know. And that helps you to do 20 questions from your book. You get the idea. This is one of the challenging questions, which will make you work in the reverse direction. We are not giving you angle now, correct? So we are giving you this triangle whose opposite side is given to you. And obviously, if I drop a perpendicular, as now we can go through the solution, the angle will be divided into 2 parts, equal parts, as shown here in yellow. Yeah. So we have hypotenuse of this right triangle as 3, and the half of that total chord length is 2.5. We get a triangle. And now using SOHCAHTOA, the sine ratio, right? Sine is opposite over hypotenuse. We can find what the angle theta is. So first thing first, find the angle theta in radians. Always use 4 decimal places for your angles. Always use 4 decimal places for your angles. Otherwise, you will not get the correct answer to 3 significant figures.
Never round early is what you say.
Clear. Now, once you know this angle, you can easily find the sector area, right? So we are doing step by step. Area of the triangle is half r square sine theta. We know that formula, right? Area of the sector is half r square theta. So we got that, correct? Subtract the 2, correct? You get your area of the water. Multiply by length to get the volume of the water. Is this clear to you?
Yeah. But didn't you say that you could use that formula half r square?
Yeah, directly. You could use.
But you're just showing how to do it like this.
Yeah, because I have used the formula, right? So this is the formula, correct? This, we have to take away from sector this, right? This is the formula. Yeah. Basically, half, this is common.
R squared,
and theta, right? Sine theta, difference, right?
Oh, yeah.
So the formula is very clear, which is half of r square, and then we have
theta.
Theta, because sector is bigger, right? Theta minus sine theta.
Yeah. It makes sense, yeah.
Because I'm just writing like this, because your part A will be find area of the triangle, part B, area of the sector, part C, volume of the water.
Anyway, even if it's even like you said, even though the equation is like that, it's better to write it out like you have, because it just leads to less error. Like when I go back and check.
Right.
But I am still using the formula, it's just perfectly laid out. So,
yeah. And because we are also actually preparing for GCSE, right?
Yeah.
So GCSE exam question will be in 4 different parts, right?
Usually, yeah.
You don't get a straight question, correct? They won't say directly find the volume of water. No, they won't say that.
They don't.
But at other places, they will say find the volume of the water. Multiple choice. The answer is 70, 80, 90, 100. So the answer is 70. Done.
Yeah.
That is what I'm saying. If you know the formula, you do like that.
Perfect. Okay.
Perfect. So do you understand this?
Yeah, very clear.
Strictly speaking, we have come to the end of this particular chapter with these 3 examples. I think we could go through this particular question, right? Can you please read this question?
Okay. So circle with external tangent. The figure shows circle O with tangent CA and CB. Part I. So given that the ratio of the major sector and minor sector area is 5:3, find the angle theta.
Okay.
Part 2, if the perimeter of the minor sector, AOB, is 26 centimeters, then find the value of R up to 3 significant figures. And finally, part 3, now find the area and perimeter of the shaded region.
Good. So as you can see in this case, we have involved some reverse calculation. Okay. So that becomes
a ratio in.
Yes. So that becomes a question for you, Annie.
Okay.
So we can take a picture of this particular thing and try it out.
All right.
So we have combined the concept of ratios. You know, the total angle will be 2 pi, correct? And the total angle is 8. So you can easily work it out, right? So we have 2 pi divided by 8 because we want to divide major and minor sectors. Is that clear to you? So that will be each. And therefore, the ratio will be 5 times 2 pi divided by 8 is 2. I mean, the other one will be 3 times 2 pi divided by 8. Okay?
Yeah.
So given the ratio of major sector and the minor sector area is this, right? So we are given the area of the sectors ratio, and we know the total circle is 2 pi, pi r square, right? So you know that. So you can now divide that also in 3:5. You could do that way also. Is that clear to you? But either way, you can figure this out. How will you like to approach? Is that okay?
Well, so just quick thing. Where did the 8 come from?
Okay. So we'll actually avoid that. 8 is the whole thing. So I am writing 5 over 8.
Oh, right? Sorry.
But we'll avoid that because it is simpler. Given the ratio of the major sector and the minor sector area, right? So we know the area is pi r square. We'll go directly, right? So we know what pi r square is. And then each will be 5 pi r.
5. And
How
then
will you do
3.
5 out of 8 pi r square? Let me
Yeah,
write.
yeah. And then 3 out of 8 pi r
3
square.
out of 8 pi r. Is this better?
Got it. Yeah,
You
yeah.
have to do 1/8 of it and then multiply by 5.
Yeah.
Because the total is pi r square. Is this clear to you? So that is what
But
you
because,
yeah.
sorry, just quickly, but because they're asking sector area, do I need to use that formula or is it fine to use?
No, because the two sectors combined will be the whole circle.
Whole set. Oh, right.
Minor and major circle. So when you combine them together, it becomes a full circle, right?
Oh, I
so
see. Yeah.
Therefore, their ratios is given to us like this. And if the area ratios are like this, it is based on the angle theta. Then that means arc is also in the same ratio, right?
Right.
Everything is in the same ratio because the circle has infinite symmetry.
Yeah.
So that makes you think a bit. And I think you'll find it interesting. How do we solve this particular question, right? You need to find area of the shaded region. That means the shown over here, right? This tangent, you know, this will be at right angles, right? And these two sides will be equal. That you know from an external source. If you have to change it, circle theorem, you get this. So that will be a good question for you to try. Correct?
Okay.
So attempt this question, and I think we can end our class here today. We can summarize before that. Do you have any questions from what we learned today?
No, it was yeah, it was. I think it was very good, detailed, and I think I just need to obviously go and practice the equations that we learned today, and see how they can be asked in different ways, and how to use the different formulas we learned according to the different situations, and what they're really asking. Because according, like you said, throughout my kind of exam questions in the UK are usually a lot of parts to it. They don't ever ask just a straightforward one. So like you said, all those part A, B, and C, D will definitely be asked.
Okay.
So,
but then keep in mind your target, year 13, you had that senior UK mathematics competition, correct? Last year you appeared for it, but this year we have to get the gold, right? So keeping that in mind, all these formulae which I'm talking to you will always help because that is a multiple choice test paper.
Yes, it is. Yeah, we don't have many of them there, but here actually. But when we do,
keep that in mind. You're definitely going to get one question from today's lesson in there also.
Okay. Yeah.
So can you summarize today's learnings and then we'll end our class?
Yeah. So we kind of touched upon what we learned with the area of the sector, the half r squared theta. We learned how to derive it, and then the new thing we learned is area of a segment. So this is the one that I didn't really know, but logically when you think about it, it now makes sense because you're going to obviously find the area of the sector, and then when using that chord length formula, or let's say you use the chord length, or you can find that triangle, you would subtract your sector area from the triangle, and putting those two formulas together, you get the area of the segment, which would be the half r squared theta minus sine theta, just by taking it out, factorizing. So the simple thing. And I guess laying it out in the format that you did just means that when I come back to it, as I'm going through the test, I can always check it more easily than just having a bunch of values and then subbing it into that formula. And then we learned how in different situations, like the volume of water one and the different application ones, you have to use the different formulas to answer those questions, depending on that question. So yeah. Great,
then we'll end the class. It was great. Perfect. Have a good day.
Thank you so much, sir. I really appreciate it. Have a good day.
You too. Thank you. Bye.